Okay, so for those of you who are watching us right now in this recorded linear algebra lesson, we're going to be working on Cramer's rule, which means we're going to be solving linear system using a matrix. All right, just ignore me. All right, so how are we going to do this? We'll start with an easy problem, because if I start with that problem, all of you will just be sleeping or muting me while you watch Netflix or play video games. So let's not do that. And we're going to be using the Cramer's rule. So the Cramer's rule is using the determinants and finding the values of x, y, z. So for example, we're looking for an easy problem, x minus 3y equal to 5 and negative 3x plus 6y equals 8. So this is a linear system. And if we change this into a matrix, it's gonna look like this: 1, negative 3, negative 3, 6, 5, and 8. So this is now our augmented matrix. We've learned this 3 weeks ago. This is the linear system in algebra, regular algebra. And this is our linear system in linear algebra. So how do we find the values of the solution? The solution of the linear system is given by x and y, which means we have two lines. This is line 1 and this is line 2. If we graph line 1 and line 2, the point of intersection of line 1 and line 2 is what we're looking for, and that is a point. That's why it's x and y. X coordinate and y coordinate. Now, how are we going to use Cramer's rule to find the solution of this linear system? We have a formula, and the formula is to find the value of x. It's dx all over d, and to find y, it's dy all over d. And what's dx and what is dy and what? Okay, so we're going to be needing 3 determinants. Now, how are we going to find the determinants or dx, dy, and d? Let's start with the determinant of d. So the determinant of d is the coefficient matrix. And the coefficient matrix is this matrix right here: 1, negative 3, and negative 3, 6. That is d. Now, how are we going to find the determinant of this 2 by 2 matrix? Easy, because we've learned this last week. And to find the determinant of a 2 by 2 matrix, we multiply this first diagonal. And what is 1 times 6? Good job, 6. Minus the determinant of, the product of the second diagonal. And what is negative 3 times negative 3? 6. And what is 6 minus 9? All right, so we found our first determinant, negative 3. Are you guys following? I hope so. All right, now the dx. How do we find the dx? We find the dx by changing the x column with the right-hand side, 5 and 8. So now we're using the Cramer's rule. So to find the dx, you cover the x and you replace the x with the right-hand side. So our new matrix is going to be 5, 8, and then the column matrix for y is not going to change. It's still negative 3 and 6. There. So that's how you find the dx. You will replace the column matrix of x with the right-hand side. So now we'll find the determinant of that matrix. So let's do that. 5 times 6 is 30. Minus negative 3 times 8. What is negative 3 times 8? Negative 24, right? So now we have 30 minus negative 24, which is 30 plus 24. And what is 30 plus 24? Unmute yourself.
Oh, 54.
Let me just look at the chat box. 54. All right, so now we have 54. Now, how are we going to find dy? We will find dy by changing the y with the right-hand side, and we will copy the x because we did not change it. So we will have x will still be 1, negative 3, 1, negative 3, and our y is going to be 5a. There. And then we'll repeat the steps. We're going to be multiplying the first diagonal. 1 times 8 minus 5 times negative 3, negative 15. So we have 8 plus 15. What is 8 plus 15? Who says negative 7? What's it? Is that right? Yes? What is negative 7? Okay, 23. So, okay. Tell me, is this correct? Is this correct? Is this correct? Yes? Okay. Now that we found the 3 determinants, now we're ready to find the values of x and y. And how do we find the value of x and y? X is equal to, the formula says, dx all over dy. Where's that? Here. X is dx all over d, and y is dy all over d. So just plug it in. Dx, what is dx? Dx is 54 over negative 3. And dy is 23 all over negative 3. Can we simplify 54 divided by 3? I don't know. I'll use my calculator. 54 divided by 3. 18. Negative 18. Can we simplify 23 and 3? Can we simplify that? No. So it's negative 23 all over 3. So the solution of that linear system is negative 18 and negative 23 all over 3. And that is Cramer's rule. Is it easy? Maybe. Is it complicated? Yeah, maybe. So let's have a recap of what we just did. So in using the Cramer's rule, you will change your linear system into an augmented matrix. Now your goal is to find 3 determinants. So the 3 determinants will be your d, dx, and dy. So the first determinant is easy because it's just a coefficient matrix. So you just use x and y and find its determinant. Product minus product, and then you find it. Now the dx, you will replace the x column with the right-hand side, find the determinant, and then the dy, you replace y with the right-hand side and then the determinant. And then you use the formula. So you'll have a fraction as an answer or sometimes a whole number. It all depends on the solution. But in this case, we have a whole number in a solution. Now, did we do it right? I hope so. So I'm going to prove to you that we did it right. How am I going to prove it to you? I'm going to show you this. Share, 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 share. All right, look at this. We did not do the first one. It's negative 3, negative 2. The second one is what we answered, and our answer was negative 18 and negative 23 over 3. Hopefully, hopefully we did it right. Yes, we did it right. So the answer is correct. So that means we're doing the problem correctly. Okay. Can you please work on number 2? Don't work on number 1. Let's work on number 2. Can you please write it down? Negative x plus 5y equal to 2 and x minus 2y equals negative 2. We will use Cramer's rule in solving for this problem. So I'm going to work it out with you. exit. I'll write the problem. Negative x plus 5y equals to x minus 2y equals negative 2. All right. Step 1, change it into an augmented matrix. So don't wait for me. You can start working because I need to do a lot of steps here. Okay? All right. I'm going to do mine. Are you seeing me? I mean, are you seeing my paper? Okay. D is negative 1, 1, 5, negative 2. Okay. So the first determinant is always the easiest. Positive 2 minus positive 5 equals negative 3. Next, dx. Change x with 2, negative 2. Copy. Determinant. Richard says, ah. Okay, the last one, dy. Copy. Change. Equals 0. Okay, tell me, do you have the same determinants? Abdul says yes. Tiffany says yes. Okay, so I can continue now, right? All right, I'm a little bit scared with this. I thought I did it wrong. So you got this 0 as well? Okay, so now I'm going to find x and y. So x is equal to dx over d. Y is dy over d. So dx is 6, negative 3. So this is negative 2, right? Dy is 0 and d is negative 3. So this is this 0 or undefined? That's right. If the numerator is 0, the number exists. If the denominator is 0, it's undefined. It does not exist. So the solution is negative 2 and 0. All right. Did we do it right? The first one? No, that's not what we're answering. The second one is what we're answering, and it's supposed to be negative 2, 0. Woohoo! Negative 2, 0. Did you get that right? So again, Cramer's rule may be a little bit challenging, but it's easier than substitution method or elimination method because in this particular method, it's procedural. We have step 1, step 2, step 3, all the way to step 238 until we get negative 2 and 0. So everything is just going to be the same. But if it's substitution method or elimination method, it takes a while because you need to think first on what you're supposed to be doing before you can come up with the right answer. And that's what we're going to do with a 3 by 3 matrix. Do you want to move on to the 3 by 3 or you need one more example? Move on or one more example? Move on. One more. One more. One more then. Okay, let's do, which one is easier? 3, 4, 5. Which one do you want to pick? Number 3, number 4, number 5? Number 3? Okay, let's do number 3. I think it's easier because it has a 0. Every time your matrix or every time your linear system has a 0, it's usually easier because it's a 0. Okay, can you please copy it? We'll answer it together. And I think you already have an idea of what we're going to be doing once it's a 3 by 3 matrix. And yes, it's going to be long and tedious. Just like what I mentioned last week, in linear algebra, specifically matrices, it teaches you how to be patient and accurate with every little step that you're working on because the math is pretty simple. But if you are a little bit careless and being too fast or quick with your answer. Sometimes you will make mistake because I usually make mistakes on problems like this. And the reason is because I always rush. So I'm not gonna rush so that we will have the same answer. Okay. See, I already made a mistake. What's my mistake? Yes, I know. This is supposed to be -20. So this is going to be 40. Did I correct it? Okay. That's why don't rush. See what happens? This one is -40 minus 0. So this is... Okay. So I got -10, 40, -40. Did you get the same result? Yes. Okay. All right. So x is dx over d. Y is dy over d. Dx is 40 over -10. So we have -4. And dy is -40 over -10. So we have +4. So -4 and 4. Did you get that? No? Hey, tell me. Okay. Carly says yes. Everyone says yes. I hope everyone is saying yes. Let's see if I'm right or we are right. Hopefully we are right. 1, 2, -4, 4. -4, 4. Now, if your answer is 4, -4, is it the same as -4, 4? Yes or no? Yes or no?
No.
Of course not. Because the reason why it's called an ordered pair, it's because they need to be in order. So it needs to be -4 and 4 and not 4, -4. Otherwise, your answer or your solution is wrong. So make sure that every time you're working with linear system, play. There. That's what I'm talking about. Okay. Now, for the star of the show, we're going to be solving a crazy problem like this. So in a 2x2 matrix, it's easier because finding the determinant of a 2x2 matrix is easy. But remember last week when we were working on the determinant of a 3x3 matrix and it takes us a while to finish it? Yes. Unfortunately, there's no shortcut. However, remember the video that I showed you? It took that person 12 minutes to complete that particular problem. And it's prone to error because there are so many fractions, there's so many distribution that's happening, there's so many addition, subtraction, multiplication, and division that is going on in that problem. But in this case, we're just going to be doing it in a system. And the system is, we're now going to be working on 4 determinants. The determinant of d, the determinant of x, the determinant of y, and the determinant of z. On top of that, finding the determinant of a 3x3 matrix is a little bit longer because remember the rule, you copy the matrix and then you copy the first 2 columns and append it to the matrix and then you multiply, subtract. Okay, you got the idea. Let's just do this because I'm hungry now and I want to eat. So let's do this problem by the linear system is x minus y. This is a true test of patience and accuracy because every little move you're doing or using is important because one slight mistake will not give you the answer we're looking for. Okay, so are you ready?
Yes.
For consolation, I think what makes this easier is we have zeros, and we know that if we have zeros, multiplying them will be a lot easier. So let's begin. Let's start with a D. 110, -1, 0, 1, 1, 3, -2. Copy the first 2. Now, we're going to do a little bit of mental math because I don't like to write too many numbers because multiplying them is easy. We can do that in our head. So let's begin by finding the first set of diagonals. Are you ready? What's that? 0 plus, what's that? 0 plus, what's that? 1. All right. So that's our first diagonal minus the second diagonal. So see, if we have a lot of zeros, things are easier. This one is not 0. It's going to be positive 2 plus 3 plus 0.
0.
Okay. And now we have 1 minus 5, which is negative 4. Did I do it right? I hope so, because I don't want to repeat this. Now, dx. In the dx, we will change this to that. 3, 6, negative 1. And then we will copy the rest of the problem. Negative 101, 1, 3, negative 2. Okay. And then we will continue. Copy the first 2 columns. And now, for the fun part. 0 plus positive 3 plus 6 minus positive 12 plus 9 plus 0. This 9 minus that. What's 12 plus 9?
21.
Hey, 12 plus 9, 21. All right. What's 9 minus 21? I know it's negative, but what is the answer? What's 9 minus 21? Okay. How many determinants do we still need? 2 more. All right. Let's continue. I think we're just going to have one example, and then I'm going to give you the homework after this. All right. Let's do the dy. Copy 110. Change 3, 6, negative 1. Copy 1, 3, negative 2. And then copy the next 2. 110. 3, 6, negative 1. Okay. Let's continue. Negative 12 plus 0 plus negative 1 minus negative 6 plus negative 3 plus 0. Okay. Now I will clean this up. This becomes minus. So I have negative 12 plus 0 minus 1 minus negative 6 minus 3 plus 0. What is negative 12 minus 1? Negative 13 minus negative 9. So I have negative 13 plus 9. I know it's negative, but what is negative 13 plus 9? Tell me. 4. Positive, negative? Negative 4. All right. Last determinant. Is there anyone here who has the determinant of z? Maybe there's someone. Okay, let's do it together. Last one. Okay. 110. Negative 101. 3, 6, negative 1. Copy the first two. Negative 6 plus 0. 3 minus 7. I know this. Negative 4. All right. Did you get it? Did you have negative 4? Okay. Now for the easy part. X, Y, Z. X is dx over d. Y is dy over d. Z is dz over d. So we have dx negative 12 over d negative 4, which is equal to positive 3. Y is dy negative 4 over d, which is negative 4. So this is positive 1. And dz, I am dz now, negative 4 over negative 4, which is equal to 1. So the solution is 3, 1, 1. All right. See that? Okay. And we did it right. Yes. Now, as I mentioned, this is pretty tedious and it's too much steps. And again, this is easier. This is the basic algebra way on how to find the values of x, y, z. Specifically, he's using substitution method. So the problem in this method is, of course, you will still get the same result, but it's too much steps and it's more prone to errors. Because in Cramer's rule, the steps is pretty much the same for every single process or every single matrix. But you'll notice here, they're multiplying fractions, they are adding fractions. So many things going on just to find the values of x, y, and z, which ended up as a fraction. So again, this is regular algebra, and this is Cramer's rule. And in Cramer's rule, we're using the matrix in solving for the problem. Okay, and this is our beautiful work. See, I'm so proud of this. I'll put this in my fridge to let me know that I did something productive today. It's nice because it has colored pens and markers. Maybe you should buy your own colored pens and markers so it will look pretty like this. Because mathematics, of course, math is a science, but it's also an art. So the art of being organized and making sure that you are doing every little steps with precision, it's a work. It takes techniques, experience, and practice to be able to come up with your own techniques and steps on how to produce problems like this. And again, this is hard because there's so much steps. And of course, we are looking for 3 different variables. From week 2, 3, and 4, we are only working with finding the value of x, single variable. But now we're doing 3 variables. And this is also true in calculus, in trigonometry, in statistics, in any math classes, that the more variables you're missing, the more difficult it is to solve a problem. Just like with exponents, the higher the exponents, the more tedious your work would be in finding the solution of that equation. So that's one thing that you need to understand about math processes. the more letters that's missing, the more fun it would be. So I'm not going to give you another example because it's too much. And I'm confident that you are going to be able to do this on your own. Don't worry, the homework that I'm going to give you will have a bunch of zeros. I'm not going to torture you with a lot of problems. That's, let's say, 25x plus 13y and negative 238. No, I'm not going to give you that problem. So just need to make sure that you know how to find the determinants. So your assignment for this week is finding the solutions of a 2x2 matrix and a 3x3 matrix using Cramer's rule. And I will post it after this. Maybe after I eat something.
You might want to eat first.
You can unmute yourself if you want. Question. Come on, give me one. Or you need more. Do you need more problems? I can give you more. I'm not going to do it. I'm just going to give it to you. And then I'm going to go to the kitchen and eat while you guys are working. Do you want that? Because I can have a lot of problems on my presentation. And I have the answer.
Well, if that
wanna
is
do that?
homework problem.
No.
2 problems on your own while I go to the kitchen and have my lunch? No, let's not do that. Okay. No more questions?
I have a question.
No? Okay. Then we'll dismiss. 2:19.
I think
We started at
Isabella.
1:30.
Oh.
Isabella has a question.
Oh yeah, I have a
Oh, that's a
question.
long one. And for the rest of you, thank you so much for coming. I appreciate your presence. If you are muting me while I'm doing all my lecture, shame on you.
More like you're
And I'll see you all again next week. All right?
All right.
Be safe. Thank you for coming. It's been fun. I'm enjoying this thing. And see
All
you
right.
all.
Bye, everyone.
Bye-bye.
Have a good day.